To determine if two events are independent, you have to first look at the probability of A given B and see if that equals the probability of A. If they equal, that means B happening doesn't actually change the probability of A actually occurring, making them independent. B doesn't affect what happens to A. To do this, we have to figure out which event is A and which event is B. It actually doesn't matter. So let's just let A be getting an A in the course. And let's let B equal taking Math 121. So the probability of A given B means that B's happened, so we know that the person has actually taken Math 121. So we actually only need to look at this row of the table of the people that took Math 121. There are only 33 people in that grouping, and then out of those grouping there are 5 people who have an A. So therefore this probability would be 5 out of 33. Next we need to look at the probability of just having an A. So now we're not given any information, so we no longer just look at this one row, we have to actually look at the whole table. So in this whole table, we notice that there are 92 people in the entire table, and out of those 92, 12 of them got A's. So therefore the probability would be 12 out of 92. You will notice that these two numbers actually do not equal. The probability of A given B does not equal the probability of A. So therefore the two events are dependent or not independent. Whoops. All right. Let's do a second example of this. This time we're going to find out if the test, if the events withdrawing from a class and taking Math 187 are independent. Again, it doesn't matter which one's A and which one's B, so let's just let A, B withdraw. And let's let B be taking Math 187. So we're going to look at the probability of A given B. So going back to our table, if we're looking at given B, B was taking Math 187. So that would be this group here. Again, we only need to look at this row. So we'll look at this row, and there are 41 people who took Math 187 out of 4 people who got A's, but we're looking for withdrawals, which would be 6 people who got a withdrawal. So this would be 6 out of 41. Now let's just look at the probability of getting an withdrawal. So again, going back to the table, now we're not told any information. So again, not look at just this one row, but we're going to look at the entire thing. Looking at this, we notice that again there are 92 people that were involved. We want to know if they withdrew, and there were 14 people who withdrew. So this would be 14 out of 92. Converting these to decimals, you're going to notice that those do not equal. So the probability of A given B does not equal the probability of A, so therefore the events are dependent. And there you have it.